Okay, so this is Chapter 6, Section 1. This is Part 2. Well, what if we go the other way around? What if we want to know what's the payment that I want? So before we had the payment of $100 and we figured out how much I'm going to have in 20 years. Well, what if I want in 30 years to have this much money? So now I'm asking myself, how much do I need to actually deposit, right, each month? Which is typically how it works. You don't really work backwards from how much money in your account. You work back to what do I want in my account in the future, right? So I want $200,000 in my account in 30 years, which is a pretty reasonable amount of money. It's not all that much, to be honest with you. So I'm going to go back and I'm going to take the formula, right? We'll take this one here. I'm just going to take this here, right? And copy. And paste. Okay, so let's work with this formula first, right? So, and you can use this in the future. So, I'm just going to call this future value of the annuity, get rid of the A, which is what the book uses, right? So, I want to know what the payment is, correct? Right? So, what I'm going to do is do a little algebra here, correct, to solve this equation. So, we'll take this equation, and we're going to multiply, right, the reciprocal. So, this one's going to go down here. And this one is going to go up here, correct? So then this one will cancel this one, and this one will cancel this one, correct? But I have to do it to both sides of the equation, correct? So times that. Whoops. I did it twice. Okay. So everything here will cancel, correct? So I'm going to be left with the payment equals this. I'm going to flip it around. So I'm going to do future value of the annuity times, right? So there is my equation. Okay? So I just flipped it around to get it to work for me, right? Because this is going to cancel this is going to cancel this, which will leave me with payment. And then there's my equation right there, right? So payment equals this. Okay, so let's read our problem now here. So we'll scroll that down, scroll down. So you want $200,000 in your account, so 200,000, right? That is your future value, right? Future value annuity. So in 30 years you'll have that. Okay, so I'm going to take this, copy, paste. So the rate we're going to be paid is 8%. And it says monthly, so that's 12. A lot of the IRAs will be monthly. That's not necessarily the case, but we're going to go with that. All right, so the number of compounds is 12, and we're going to go 30 years, basically. Okay, so I have 1, 2, 3 parts here, which I'm going to put into the calculator to get my actual payment, which again will be an approximation. Okay, so I'm going to cheat here. I'm thinking maybe can I copy that maybe into the spreadsheet? Let's see if I can do that. So I'm going to go to my spreadsheet. So this one goes up here. That's the one we did before, right? Can I get it in there? I don't think I can. I think I have to go back here. And we'll shrink it down, right? Whoop, I got that a little big. Okay, so we're going to go down to here. So this is the things I want here. So I'm going to put in the 200,000. Oh, equals 200,000. Okay, so the other parts are equals 0.08 divided by 12, right? That's the numerator. And then the denominator is right here, right? So we want equals 1 plus 0.08 divided by 12. That's the part I forgot last time, right? To the power of, parentheses, 12 times 30, close paren. Okay? So notice that all in parentheses because it's all to 12 times 30, which also needs to be in parentheses. And just the minus 1 goes on the end, right? So that'll do it first, and then I'll make sure that all goes to that, essentially, right? So I have my 3 pieces here, right? So my payment, right, is going to be equal to, right? So I'm going to do this times this divided by this, right? So it's 200,000 times this divided by this, correct? Right? So notice I'm doing it in parts, right? You can go back and watch the video a little bit slower. You can get more decimal values if you want by getting that bigger or smaller, right? So you keep going out. I don't know, we'll say 1958 is good enough. Okay, so we'll go back to our thing here. So MATH145.1958 ... Okay. Okay, I like that. So we're kind of working backwards using the same formula. All right. Let's go to the next page here and look at one more example. Let's say you invest $250 a month for 5 years into an account that earns 4% interest compounded monthly. After 5 years, you stop making deposits. Then you sit in the account for additional 25 years. So originally you thought it was going to be an annuity, and you did that for the first 5 years. But the 25 years after that, it's no longer an annuity because you're not making payments anymore. At that point, it's just compound interest because you're just letting a set amount of money sit there for 25 years, which is what we did in Chapter 5. Okay, so I'm going to go back and steal the formula again because we just need this one here. I'm going to steal that right there. Okay, and we'll go down to here and plug this in. Okay, and we'll go to the spreadsheet after that. Alright, so the payment that I'm putting into this is $250. Okay, the interest rate on this is 4%. The number of compounds, it's monthly, right? So 12. And so 12. But the time period is only 5 years, correct? Right? So again, that'll be an approximation. So that's the first 5 years, right? And we'll get a dollar amount, right? And then after that, we're going to take that and do the A equals P sub 0, right? Because that's the initial principal. Okay. And then 1 plus R over N to the NT, right? That's the previous chapter, which is just compound interest. So it's only one amount. That's why it's P0, correct? Because we don't keep making payments when it's just a regular old compound interest, right? Okay, so we'll fill that in a minute because we need to know this answer for the first 5 years, correct? Okay, so I'm going to take this, copy it, and go to my spreadsheet here. Okay, and I'll attach the spreadsheet too to the lesson so you can look at it. Okay, so I think I'm going to do the 250 here, right? No, I'm sorry, equals 250. And then equals, let's see here, parentheses 1 plus 0.04 divided by 12 to the power of 12 times 5, and then put the minus 1, right? So I have the 250, and then I have this part over in the other box, right? Just double check. I did divide by 12 that time. I didn't forget. And on the bottom, I have the 0.04 divided by 12, right? So that means my future value of the annuity equals the 250 times this part, right, divided by this, gives me my value there. So we'll round up to 75 cents, but that's good enough for now. Let's go back to my document here. Whoops. So we need to put in that amount we just got, which was 16,574,000.7445 ... I think then double check here. 5745. I think we're good. We're good there. All right, so we're going to translate that down to here. So because we're going to copy this. Again, you're doing this by hand. I'm typing, obviously. 16,574.75. And the rate is 0.04. The number of time periods is 12. And is still 12 for compounds. But this time period is not 5. This is 25, right? Because again, 5 years I made payments. 25 years I didn't, right? So 5 years I made no payments. I did make payments, sorry. I made payments for 5 years. Then I didn't make payments for 25, right? So annuity versus just regular old compound interest, right? All right, so we got to green this one because it's both answers, right? So that's an answer. Okay, so we're going to take this to the spreadsheet now. And we'll scroll down a little bit. A equals. Okay, so 16,574.75 we gotta put an equals in there. I screwed that up. Equals, okay. And then this box over here is the 1 plus 0.04 divided by 12, and then 2 to the power of 12 times 25. I think we're good there. Yes. So all I have to do is multiply those, right? So A equals, and I need to multiply those. This times this, right, to get the two parts together. And there is the amount I'm going to have. So 9790. Okay. Alright, so let's go back to here. So I believe that was $44, comma 979.979 dot dot dot. Double check. 979979. Is that? Yep. And then 0.05, I guess. That doesn't really matter because it's going to be 98 cents anyways, but I'm just going to leave it like that because the rounding is going to specify a certain way, and it's either up a penny or down a penny depending on what you're doing. Typically, the way they work, if it's in the bank's favor, they round down. If it's in your, I'm sorry, they round up. You know what I'm saying? If it's in your favor, they're going to round down. That's typically how it works, essentially. Okay. All right.